So, you started with trig, but you have no idea where to begin. Here's a couple of tips I can give you right now just to kind of get yourself settled in, get your mind focused on what you need to understand as far as trig and where it starts. Of course, most teachers will have a review of previous algebra, and algebra is always the first thing to keep in mind that it's going to be affecting any class you're considering, from stats to calculus to whatever other mathematical or mathematically expressed profession you seek, to architecture, engineering, and so forth. But algebra is going to be essentially the grammar of math, so that's why it's basically everywhere. So one of those concepts that will come back forth to haunt you if you're not good with kind of the K-12 space, if you're still in K-12, or if you're going into college, you're brushing up on some algebra, and you're wondering where it can affect you. As experience goes, most students that go through a community college that I've worked at in the past, well, they end up thinking that trig or calculus is difficult, even statistics, when in reality it's the grammar that they hold is not as good as the grammar that the students not struggling hold. And what that means is they just forgot some stuff from high school algebra, maybe some middle school concepts from math, operations. Maybe they didn't practice a lot of their usage and calculating skills to kind of like strengthen the logical side of the brain. But regardless, algebra is going to exist in any of these. And I normally consider algebra the grammar, and with any grammar, each one of these differences as far as trig, the only difference here is vocabulary. What are you using? Vocabulary, what are you using? The grammar is still the same, but now that's a specific subject we're focusing on. So always consider that as a fact too. Of course, as far as vocabulary, we're going to go straight into it. We've got sine, tangent, cosine. No particular order. Those are going to be the main pieces that we're going to be using when we're dealing with anything involving trig. So the first key to remember here is that we're kind of working in a different environment. When we're dealing with normal digits, we have some equation equaling mx plus b, which we recognize as a linear function or a line. Has 2 points, has an infinite to the right, has an infinite to the top, and down and left, and so on and so forth. So those are the kind of adjusted places we've been before we enter trig. Trig goes into a kind of limited space. We call it the unit circle. In fact, there's going to be a bit of a difference that I'm going to separate these two graphs because we're going to have some similar concepts that are going to kind of reflect between the two types. So we have the unit circle in our trig space. In reality, we kind of have a separation here. And the reason why we're kind of in trig right now is in this circular limitation, we don't go anywhere outside of it. So all of our graphs, all of our particular x and y coordinates will only be within the boundaries of the unit circle. And because of the name unit, any radius from the center, ignore my horrible connection there, or my centered circle, but any radius is going to be a one value unit, a single unit radius, because our interests are more in the decimal space, which in one way or another, statistics has the same interest, but more for probability's sake. So we have trigonometry interested in it for the percentages sake, the percentages of a circle sake. So we'll be using a lot of decimal values, and most of our math will be simplified to some sort of decimal rounded to 3 or 4 different values or decimal counts. So within these two realms, we do have some concepts we have to realize. First, what we would call the right or left side is radian, and on the right side is degree. These two countering aspects change some ideas for us. First, we know x and y values are the main focus in a radian space, meaning that any movement is based on an x and y axis. For any degree-based movement, it's based on a degree movement or notion. And normally, with whatever degree we're using, we're starting from this starting location and rotating counterclockwise at that degree value. And whatever that degree value may represent, as in a number, 50, 100, 90, whatever, we will then look at that location on our unit circle. Grab the x and y coordinates of said location. Let's say that this location would be something like 30 degrees. We'll take 30 degrees and say, all right, let's use that within one of the functions. The way you can remember how and what to look for is that in kind of a reflective notion of x and y, cosine is values of x, sines are values of y. Anytime we plug in this theta, this degree, in one of these two, we're going to seek an x answer if we're using cosine, or a y answer if